Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Thanks for sticking around. I've come to realize through experience that the only thing standing between you and the flight is me, and what is worse is standing between you and your lunch, so I don't feel so guilty after all. Here is a small statement that I adapted from Richard Feynman. I'm a big fan of Feynman. I work for the Network for Computational Nanotechnology, so everything I do has to do something with Feynman, okay? So we have to use him in various forms, and this is the way I choose to use him. If you note, I've not started with the title of my talk. I'm clearly masking it from all of you because the moment I mention education, there'll be a mass exodus out the door, so I'm trying to prevent that. Here's another quote that I'd like ask of all of you to read for a second and then reflect. This is the 21st century. We have access to information virtually all the time. We are inundated with it. We carry around devices that are called crackberries that keep us busy even at night. We live with our emails most of the time, but still, when you get into that classroom, nothing has changed. Okay? But here is a former US Secretary of Education asking for us to call for a radical change in the educational system and then going with all child left behind. Oh, sorry, I should have said the other way around. So what we speak of is still this. Formal courses at schools and universities, workshops of various kinds. You have a new software tool, let's offer it as a workshop, okay? That's the way you're going to let people learn. Then you have seminars where people come in and talk about what the educational vision is. Then you have a lot of software tools out there and web content with bulky multimedia, okay? This is not small graphics or anything like that. It's just huge bulky videos out there people are trying to stream on the web. And then you have some programs focused at underrepresented and underprivileged communities. What I'm here to argue today is the student community is the underrepresented and underprivileged community on the whole. What we as scientists have failed to do over the last years, or despite our best attempts have not succeeded, is in providing clear-cut innovations in educational science. There is a decreasing insight into learning. Despite all our 40 years of attempts in teaching students MPI, the number of students in computational science today is a lot lesser than they used to be 20 years back. Now, you figure out why, and you'll get the Nobel Prize, okay? Oh, well, there is no Nobel Prize for education, duh. Then there is real minimum innovation, right? I mean, every tool that has ever been introduced as an educational tool has been an offshoot of some commercial venture. I was at a forum a couple of weeks back where I had people from NSF and several other national agencies sitting in the audience, all of them educators, and I asked them a very simple question. Name one tool, one software tool or hardware tool or any educational technology tool that you asked for. You know what I got as a response? What? Ruler. Oh, no. Rulers were invented for tailors. You know what I got as a response? Complete silence. There is not a single educational tool that was invented because some educator asked for it. Okay? Oh, you can argue about the stylus, but that still doesn't hold if you look back at history. So here I am trying to argue that cyber infrastructure science can actually make a difference, and I'll tell you why. There is also an ever-widening gap between discovery and learning. Over the last couple of days, I heard talks that are really at the cutting edge of science and technology, but yet our classrooms are severely confined by what happens within those walls. Well, yeah, you put a laptop on there, and you think that students are going to learn, but unfortunately not. And I'll go into some of the reasons as to why and what we are trying to do to amend that. What would be very surprising is that's a picture from 1800 whatever, okay? And that's a picture of a modern classroom with a laptop. Well, students here are clearly using a laptop from a company that sells apples. But what you will notice is this kid over here in the corner is actually still writing something. Oh, you have the laptop, why aren't you using it, right? And also you don't know if they're checking their emails or chatting with somebody, checking into the flight or whatever else, right? It's pretty much the same as what we do. We sit in the audience here and I'm guilty of it as much as anybody else. We all try to check our emails. Very rarely do you have 100% focus, right? So you put a laptop in the hands of students and have a chat program on there. What happens, right? Every institution is pushing for e-learning, okay? Let's introduce a course management system, and that's going to solve all our problems. And then you have significant pressure to be early adapters, okay? I'm not saying, I don't have anything against early adapters. If everybody is innovating, there is nobody adapting, so there's no use for your technology. However, there is no innovation, okay? There is zero innovation happening today in the education community. And then pedagogy still revolve around the same old practices that have been existent all along. Although there is significant research showing that students are moving away, okay? They are not paying attention to what you're saying in your classrooms. Surprise, right? And then teaching and learning is once again about resources that you have in the classroom. If you have a whiteboard in the classroom, I use it. What about what happened to all this grid thing people are talking about? Why aren't we using that in the classroom? Now, having said that, I'm going to swear, okay? If you're interested in finding out what kids today are talking about, that's what they're talking about. Somebody asked me what Zanga is, okay? And if you come up after a MSN search or a Google search and come up with a statement, oh, it's a blog. Now, I've lurked enough user groups to understand that it's not just about a blog, okay? It's not just a blogging service. Well, let's use it in a sentence. Has anybody figured out what a Zanga is yet? Well, what?
Doing a 360 in the skateboard.
Oh, yeah. Cool. I take it as you say it. If you figured it out, you know. So they talk about these things called eProfs. Anybody know what eProfs are? Apparently, it's fueling a $200 million economy at Sony, okay? So I don't know what this is, but if somebody has figured it out, please tell me. They talk about zap cams. How many of you have heard of a zap cam? How many of you have a cell phone? Come on, it's interaction time. It's the last talk of the day, and you know you're all supposed to be happy and cheerful that you're all getting ready to go. How many of you have cell phones? All right, much better. How many of you have cell phones with cameras on them? Those cameras are called zap cams. Okay, students use those apparently, but I didn't figure out till I was doing research for this talk. Okay? And then they talk about a gaming life. They talk about Moblogs. They talk about the internet was always there. And then they talk about if it's not 60 gigs, I'm not ready to wear it, okay? So that's the population that we have to talk to. And that's the population we have to try and structure our learning towards, okay? And now if you're a high school teacher and you have these kinds of kids in your classroom, think about what's going on with your head, right? So you probably are thinking, how am I ever going to reach these kids? And then they come to colleges and universities. You're stuck with this whole paradigm of keeping them engaged, okay? Perhaps when we talk about engagement, we should be talking about imagination and curiosity and how to kindle that among students. And I'm going to present some of the things that we are doing that will actually address some of the concerns that I've raised. Okay? The true challenge is if cyber infrastructure science is really poised to change the way people do science, technology, and so on, let our education system reflect that urgency. If we really think that the next cure to cancer, or the first cure to cancer, would come by using cyber infrastructure tools, why aren't our students having any part of it? Maybe because they are too difficult to use. Have you ever tried using the TerraGrid? No offense to TerraGrid, folks. I come from a site, TerraGrid site, and I know what are the challenges. I know Karan there is laughing because he knows all about the complexity. You have to first get yourself an account, okay? And that's a very elaborate process that involves review. And then you go out and somebody actually reviews whether they can give you 30,000 SUs or not. And if you're lucky enough, you get a letter by snail mail, not even email, okay, that tells you that, oh, you've been granted 30,000 SUs, and you may start working if and when you get all the letters from the rest of the sites. Okay, and then they mail each one of them in with your username and password on it. God forbid privacy, right? Mail never gets lost here in the US. So if somebody takes your packet with your username and password on it, bye-bye TerraGrid account, okay? And then, after all this, you have to go to your CA authority somewhere and get a certificate, install it on your machine, and you're trying to explain all this to a kid in a classroom, remember, right? So after you've done all this, if you're lucky, you can probably issue your first ls-l command at a remote site. Okay? Oh, then there is the problem of installing Globus on your machine, GT4, making sure that the certificates agree, you have the right folders in place and all that stuff. But hey, when you're busy doing all this, your students are dropping out of college. Okay? So what I'm talking about is not just education. This is about cyber infrastructure science and research and development at its very best. What can you do as a cyber infrastructure scientist? Oh, well, first of all, I have to define cyber infrastructure, right? Well, it's complicated. I'm going to leave it at that. I'm going to present to you the case of the nanoHUB. This was an actual incident that happened to me, which shocked me into reality. Okay? I work for the Network for Computational Nanotechnology. I have a 50% appointment. I drive the educational technology agenda for this group. So nanoHUB has a variety of content on pretty much all the broad domains of nanotechnology on there. Okay? If you're interested, you can go check out www.nanohub.org. And apparently there is a breakup between some internet service provider for two companies that provide access to Purdue, so you may not be able to get in today. So it's not Purdue's network going down, it's just the internet service providers just didn't agree on something. I don't know why. It's a news report. And there is a large variety of content on a number of topics here. Okay? What is really cool about the nanoHUB is that we don't stop here. There are a variety of other tools, such as simulation tools, that you can have access to. And we have also started developing student-focused things called learning modules, which are a collection of seminars, quizzes, tools, etc. So I am really excited about this, and I'm talking about this at the NSF site review this year in June. And then I speak about how there is an expert actually giving an overview of molecular conduction, and how you can actually launch a grid job through a GUI, and how you have quizzes to actually get feedback. And after I do all this, I am also talking about how there is interoperability here and how we can, distribute this content to everybody in the world without any problem. Anybody with a course management system, which is compliant. So we take all this content, we wrap it into XML, pretty much standard compliant, and then we distribute it to national repositories like Merlot, and also it works with any other course management system. What it has done for the nanoscience community, or computational nanoscience community, is it's created a lot of users, and by going standard compliant, it's really starting to get us into the thousands of users now. So I'm all proud, I'm sitting there, and then 4 of the NSF reviewers basically said, great talk, let's talk to you outside. Okay? They're basically asking me to go out. No, you know the consequences of such an action. So they take me out and they go, so I'm at the airport, how am I supposed to do all this stuff? Can I do it on my cell phone? Can I do it from anywhere there is no connectivity? So all your technology that you're talking about really is not helping my kid, is it? Those are the kinds of questions I'm getting. So it made me realize, despite our best efforts to extend this infrastructure, by the way, I'm going to talk about the middleware that drives this, and why this middleware is also going to help us answer their questions at the next site review. But despite the fact that we have thousands of users, we are still not getting students. Okay? These are all researchers, scientists doing whatever they have to do to publish. And if you look at their agenda, education is not anywhere on the list because it doesn't count towards tenure, right? So anybody will tell you that you may be a great teacher and be named the National Science Foundation Teacher of the Year or whatever else, but still it doesn't get your tenure. So therefore, this vision. Finally, now that I've set up the stage, I'm bold enough to introduce the word education over here. Okay? So Zecosystem is based on the assumption that learning experiences of the future will be multisensory, engage significant power, such as the TeraGrid, Open Science Grid, whatever grid, or Condor clusters, whatever it may be, invisibly and continuously. The moment you tell your student, oh, this is science, you lost him. Okay? So it's about kind of hiding the science and kind of sneaking it in, if you will. And also setting this up so that it's completely engaging. Okay? Here you have a student actually history student working in a Chinese garden, which we created for his or her class. I think that's a him. And here is a student working in a chemistry project called catalysis, where they manufacture a number of chemicals synthetically or in silico, as people might call it, and then they examine its characteristics, and this is funded by the petroleum industry. You can imagine what the relationship between catalysts and petroleum is. So what is the Zecosystem? Zecosystem is a concept where learning coexists with students' lifestyle, technology choices, and the emerging national cyber infrastructure. We are about creating cyber services that transform even mundane day-to-day activities like visiting the cafeteria or chatting with your friend, or if you're at Purdue, visiting the Harry's chocolate shop in the evenings on Fridays, and you know why students visit there, to really learning experiences. Okay. On the left here, you have a student who's visiting a library to retrieve a CD from Beethoven. Okay, it's a music student, and the student is actually trying to figure out the notes of Beethoven. Instead of actually listening to it, it's not only fed to him auditory method, but also it's visualized on a tiled wall for him. Okay, so the student not only sees how the music looks, but it's also hearing it at the same time, and then there is a device there that allows the student to actually play the music and hit those notes and see if the spikes match that of Beethoven's. Okay, if you think that's utopic, that actually exists at the House of Blues in Vienna. Okay. And here is a situation where students play this game, Forza Motorsport, all the time. I know that there is a club at Purdue that does it. And I'm going to talk about how these things are related, okay, and how cyber infrastructure is actually relating these. By the way, as I already mentioned, Generation Z students, or the students that are just entering colleges and universities, are no strangers to superior computational capacity. But the trick is that they just don't know about it, okay? Here is an Xbox that's going to be released November 22nd. I'm so looking forward to this. It's got 1 teraflop raw computing capacity, okay? Yeah. So PlayStation 2, 6.2. They're going to upgrade it to meet that of course, Microsoft product, because everybody wants to compete in that space. And then you have iPods, which are 60 gigs of hard drive people carry around. And then you have all-in-one communication devices that not only store your calendar, but they also pretty much do everything you want. You can chat from them, browse the web from them, and so on. By the way, all these things are the technology arsenal of a student today. Time magazine published an article, I think it was in June or July, which spoke about being 13, okay? And they listed all of the technology choices that students make. And the technology was all these devices, okay? There's no mention of computers. There's no mention of television because, I don't know why, because students probably think that if the internet was already there when they grew up, television was like, you know. Yeah, I know. So they basically named all these devices as the standard arsenal, okay? Your students are looking here. And where is your information? Not in any of these things. Of course, there are people working on research projects that can introduce information in a format that's viable for learning into all these devices. Now, imagine this use case scenario. A student at Purdue is a major in material science, okay? And he or she has taken a couple of courses in materials modeling. And the assignment for the day is to win this game, okay? Forza Motorsport, right? This is a utopic scenario. I'm not saying that, you know, this game already has this capability, but it should ideally have this capability. And the student is playing against some other students in his or her class. Could be another student at MIT, I don't know. So the student uses his or her cell phone to access the global hub, which is a climate change hub that is just being reviewed by NSF for funding, okay? And by the way, the elements of this, all the data necessary, we got a grant from EMC, the storage company, 32 terabytes to prototype this concept, just to see if we can do this with students, and I have access to climate change data and so on. And that includes Doppler data and so forth, okay? So the student accesses the global hub and gets real-time information about Indianapolis, where they're going to play this motorsport game that day. They've selected the site. The telephone, of course, communicates with your gaming device, and all the information about weather that evening says that it's going to rain in Indianapolis, but the student is desperate to win. So and by the time the student has done this operation, Global Hub reports to your course management system saying that, okay, first task complete, okay? And then the student, in order to win, wants to model the front fender of the car by changing the materials, maybe including more carbon in it would make it lighter, and therefore get a little bit of a gain. Maybe changing the rubber on the tires would probably give more traction on a wet track. Whatever it is, they'd go to the nanoHUB where there are materials in simulations, okay? And they go ahead and do a simulation, and the nanoHUB reports to the course management system the student is done with the second part of the assignment. And of course, whether the student wins the game or not is immaterial in this context. Of course, we'd like the student to win because he or she is a Purdue student. But once the student has done these two activities, they've basically completed their task. Now imagine you as a professor assigning your student the following homework. I expect you to play about 2 hours of video game. Okay? That's the assignment. Instead of all the calculations, whatever else. If you think this is too far-fetched, I'm going to show you examples of why it's not. Okay? So how do we get there? We have this notion of infrastructure. I mean, this is a standard chart that you see everywhere. People talk about middleware. People talk about science gateways and so on. What we are doing is piggybacking on the science gateways. In this case, the nanoHUB and the global hub. Okay? And we want to make this device independent. All right? Because right now, in order to access any of the software tools that's available on these science gateways, you actually go to a website. And many times, if it has to run on a Mac, there are problems with it. I don't know why. Because people write more code that runs on a specific platform. So we are trying to build ecosystem services on top of this so as to facilitate a neural learning environment. By neural learning environment, wow, my Indian accent always doesn't make me say that word right. Okay, so if I don't say it properly, you can ask me to clarify it again. So here in this concept, what we want the learning environment to do is to adapt to the learner, not the other way around. Invariably, when you enter a space, you are the person doing the adapting. Okay, the space just remains static. It doesn't do anything for you. Okay, well, if you provide a number of drops in a wireless network, maybe it does, but then that's where it stops. Okay, but what we want to do is make the environment change to the learner's request, learner's profiles and characteristics. So in order to do this, we have a collaboration going between the Purdue Cyber Center and the Discovery Learning Center. The Discovery Learning Center is getting a new building, okay? And we want to adapt the building's design in such a way that we can actually put in sensor networks, we can actually try out new things. So we are getting ready. This is a project just starting up, okay? So we're getting ready to actually design the building so that it can allow our vision of a neural learning environment to actually come true, where we can prototype this and then extend it throughout campus. So we have lots of middleware research going on. We have research in the social and behavioral sciences going on. We have user experience analysis. And of course, all this doesn't make sense if you're not sure whether you're actually facilitating learning or not. So we have pedagogy and impact assessment research going on with this too. I'm going to focus a little bit on each of these areas. Some of these areas, the work is just about beginning, so there's not much to report there. Maybe next year when I come in, I'll have more to report. But in some other areas, there is a lot of work going on. Okay? So let me talk briefly about the middleware research. And we want to extend the middleware that's available through the nanoHUB in order to be device independent, as I mentioned a few minutes back. So right now, if you go to the nanoHUB, you can actually launch a tool. And these tools are built primarily at Purdue as part of our web presence strategy. And what the tool does is it goes to a physical machine, which in turn launches a virtual machine. Okay? You may ask, why not just give random access to a physical machine? And if you really think about it, there are lots of issues of security and so on, and people want a sandbox to play in, and so we go with the virtual machine technology here. This virtual machine technology is called Invigo. It's developed by University of Florida, and all this work is, of course, funded by one of the largest middleware grants that NSF has ever made, and our group has it. Okay? And if your job on the virtual machine takes more than a certain amount of time, I don't know exactly at what point it decides whether it should shuttle off the job to the grid or not. Right now, it talks to a Condor job manager, and it schedules it for you on a Condor pool. We are also able to forward the same job to the TeraGrid. So you can actually click a button on the GUI over there, and the job gets forwarded to the TeraGrid. Incidentally, our group also, my colleague Sebastian, who's a co-author with me on this paper, is also the PI, is a co-PI on the CMS Tier 2 site at Purdue. Okay, so that involves working with 2 different grids. So we are having problems with the usability support because some physicists want access to a different grid than some other people. And I know Tony is nodding his head because we were just talking about it earlier today. And so we are working on how to actually make these 2 grids interoperate. Okay, now what does it mean for learning? You remove the device independence by moving away from the browser, okay, and now replace that with a cell phone or a gaming device or whatever else. Then you have access to the rest of this infrastructure, okay? And incidentally, you can forward jobs between the Open Science Grid and the TeraGrid in a few weeks because we will have completed that work, and we will demonstrate that, well, it's kind of required for our site review that's coming up in February. So we'll demonstrate interoperability between these two grids, okay? I don't have to re-emphasize as to how critical a path that is in order, and what steps we've taken in order to facilitate grid interoperability over here. So we are working on the concept of mobile science gateways where we are targeting a couple of devices, Motorola and Nokia. Motorola has some smartphones which run the .NET framework. And of course, J2ME is also quite prevalent. We picked these two devices because they kind of target like about 60 to 70% of the user group on Purdue campus. And we are using the nanoHUB to prototype some of this. So we want people to be able to use the cell phone that they have in their hands to launch any simulation on the nanoHUB. Now you may ask, why are you going through all this effort? And of course, if you think back about what I've told you in terms of what devices students use these days, it makes perfect sense for learning that you would put your learning where students are looking. Okay. Of course, I'm able to answer the NSF reviewers at next year's visit, but I will pull them away from the door and say, okay, now you can actually do this thing. So we are extending the same concept to a technology transfer to the global hub. To give you a couple of details, of course, we are using both .NET and J2ME. We are using, I think, MIDP 2.0 profile on the J2ME side of things. And we are really looking forward to 2.0 version of .NET coming out because it adds a lot of capabilities that are kind of difficult right now. We are expecting some of the prototypes to be delivered at the end of fall. And, of course, more resources faster it goes. We're also doing a lot of middleware work on data visualization, particularly because if you look at gaming and if you have really complex imagery to manipulate and if you have very complex scenes to create, rendering takes a very long time. Previously in colleges and universities, what used to happen was you give a rendering job to a student, they would stick a paper on a machine that's doing the rendering and say, come back in 2 days, this machine is rendering, don't turn it off. Okay? But what we've done is through this architecture, we've actually enabled them to submit a job to a Condor pool, and we harvest spare cycles everywhere on campus to submit rendering jobs. So at night between 2 and 7, about 2 at night and about 7 in the morning, there are about 3,000 machines that come online and are able to handle the rendering job, which is facilitating some of the gaming work that we are actually doing. And of course, the offshoot of this is faculty members have stopped diluting the scope of the problems they give. Instead of having students render like 2-second jobs, they're actually asking them to do serious scientific visualization. We're also looking into ParaView, which is offered as part of the TerraGrid CTSS, to see if we can actually do real-time manipulation of images. Last week, I was at the iGrid conference where they showed how the CineGrid is able to manipulate images from a director sitting in Oakland. The music is coming from the hall that we were sitting in, and everything was streaming off of some servers in Tokyo. Okay? So the bandwidth is really not a problem here because Purdue is looking into this OptiPuter technology to see if we can actually jump into that and use that for some of our rendering purposes. Of course, to the student, all this is completely masked because from within their front-end GUI that allows them to manipulate the images, they can just select instead of render, they can say render on the grid, and it goes off and does its thing. So right now we are adding capabilities to report whether the rendering is progressing well, to track the job, where it is on the queue and so on, and we also want to deliver this to the student's cell phone. So I saw an image with a couple of students sitting at beer and checking their cell phone. I don't know who showed it this morning. That may really be the case when we are done with this project. And of course, the future work is focusing on linking this middleware to the TerraGrid. We've run successful jobs from SDSC to Purdue and vice versa, but we've not yet extended it to the other TerraGrid sites, so that's still a work in progress. And we want to offer the entire visualization package that we have using open source renderers so that it can run as a web service, so anybody doing a scientific visualization can call on those web services and render on the TerraGrid or any other grid that we support at that point. So game-based learning, as I mentioned, is a serious effort, and you see that Tony was saying in the morning that the graduate students are best to target. In fact, much of this work is powered by graduate student labor, okay? And these students are actively publishing, they are doing gaming development, and they're also thinking about pedagogical concepts. So they take courses in computer graphics technology as well as in educational technology, okay? And by the way, because it's focused on chemistry, they have to take some introductory chemistry courses too. So these are hybrid students which are spanning multiple domains. And of course, much of the programming is done using C#. It's completely, there is no C invoke or anything of that sort over here, so it's completely true .NET, okay? So we can actually offer some of these services that we are building as web services too in the future. So the real questions that we're trying to answer are these. These are pedagogical questions, if you see. But what I'm showing here is cyber infrastructure work that we are doing is powering the pedagogy that people have in their classrooms. And it is really not about teaching MPI or parallel programming to students, okay? It's about what you teach. Is it facilitating real science is the real question, right? And if you want to facilitate that, you have to put certain kinds of efforts in place so that you build the tools necessary. What are the tooling problems over here? There were none, okay? We are starting to build them out with the non-scientist beginner in mind. And what does it do for the scientist? The same threshold of entry would also be lowered for them, right? If you think about the cell phone use on the global hub, there are farmers in Indiana who want weather prediction on their cell phones at real time. Okay, they want to see how disease vectors spread. Okay, so all this technology that we are building actually facilitates real applications even on the scientific end of things. So it's a two-way street. Of course, all this is also predicated on the fact that you understand social and behavioral work, behavioral aspects of how students behave. Okay, what does it say about a student that he or she is at a certain place at a certain time in the day? What are the social and behavioral characteristics of the student? Can you understand this using some kind of profiles? What are their cognitive profiles? So this is a serious challenge, and it involves uncertain data management. Okay, one of our colleagues, Sunil Prabhakar, is actually leading this work on uncertain data management. He actually asked me to mention specifically here that right now he's using Postgres, and he would much like it if he would be able to do this with SQL Server also in the future. Okay. So clearly there are a number of problems. I'm no expert in this area. It's mostly Sunil's work that I'm presenting at this point. Okay. So if you have any questions, I can forward them to Sunil, or you can write to Sunil and find out what he's thinking. But his work has significant repercussions for the work that we are doing. Okay. And also, if you have noticed, this is highly interdisciplinary work. We have pulled in a team in multiple domains. We have computer science experts, social and behavioral science experts. We have people who are working on middleware, on visualization, game-based learning, and so on. And of course, subject matter experts, for example, in chemistry. This is the team. As you can see, it's divided in a number of different areas. After a very long and trying effort, we finally have a team who can work on this big problem with us. Okay. Having said all this, I know I'm the last speaker. I have a couple of minutes, so I'll stop here and pause for some questions. And if you have any, if you are, as somebody pointed out, if you're very shy, please feel free to drop me an email. Thank you. Yeah.
The kind of environment you described is highly immersive and extremely, how can I say, stimulating, if you like. It seems to me that how then is this environment teaching students to think for themselves and be able to motivate themselves in a kind of calm, contemplative state, if you like?
Right.
Is that a problem with current education, with just the kind of state of play of technology nowadays, that we will expect to see students who are expecting everything kind of laid out in front of them, rather than having to kind of engage with the subject and try and ask questions of it and bring the subject towards them? Are we going to? Do you think that we're going to have to deal with that as educators?
Right. It's a very critical question. That's why we have a pedagogy and assessment team working on this. It has to really spawn the imagination and curiosity. Okay, that's a requirement of our project. So how are we going to do it? One of the significant predictors of success in a classroom or success in any course or in a field of study is time on task. Okay, followed by well-structured instruction as to, if you have a faculty member who's actually driving certain questions, and then you inundate the student's field of vision with the right kind of information, because they're looking at cell phones and gaming devices and iPod and whatever else. So our assumption or our hypothesis at this point is as a hybrid strategy is going to pay off. Okay, and all indications, we talked to a lot of experts both at the National Science Foundation and outside, and the consensus is that yes, it will work because you're increasing the time on task. Okay, They don't realize it. It's very tacit, but you're constantly adding to the amount of things that you have in their field of view. Okay, but that being said, this is a true pedagogical problem, and I don't have an answer to it. Okay, this is something that we have to think about. This is something our pedagogy and assessment team has to work with us. That's why every member on our team is actually focusing on this problem too. Okay.
Dr. Manhavana, which country are you coming from?
Oh, I come from India, where we don't have all these technologies, and you asked me how I got here.
No, I'm from Poland. I'm from Poland, and actually that's part of the answer to what I'm trying to say. See, I think basically you're talking about the American problem. This is American problem. The best programmers right now, the best research, field-based research was in India, in India Institute of Technology. And actually he said that that's the best programmers he's getting out of India. He didn't go to MIT, to Stanford, or anybody else. He went to India. That right now he's claiming that his youngest research lab, the one in China, is the most productive one. The reason for this, I think, is not because how we're going to deliver education, but whether it's undesigned, is perceptive education. Trying to treat somebody is sort of like, like a mother who's giving a bad medicine, sore medicine to a kid, putting it in a sweet coat. It ain't going to work, as you said, Sam.
Yeah, absolutely. Okay, I agree with this assessment that some of the great programmers are coming from other countries. But if you see, in a population of 1 billion, the chances that you're going to draw on successful programmers is higher than in a lower population. Okay, so you shouldn't be under the assumption that the Indian education system is somehow spawning all this. The real trick there is when you're working with 1 billion people and 500 million of them are graduating each year from colleges, the chance that you're going to pick up the cream of the crop goes up significantly. Okay, I know because I came from this system. So you compete in every stage and they filter you out based on sheer numbers. If you are in line and you hand in your application for college, and the next guy has as much grades as you, just because they have taken in 1,500 applications, you get cut off. Okay? So there is a natural selection in the Darwinian sense of this. Okay? So don't please say that.
I guess maybe you missed my point. And you are absolutely right. Actually, the guy who started China Lab says that if you are 1 in a billion in China, it still thinks that there's 1,300 people. So yeah, that's absolutely true. My point is, it's like beating a horse. If you only have a shovel, that's okay. I need the 1,000 to do it. But if I have a big machine, I could do it much faster. What I'm saying is infrastructure in this country, the amount of spending of education is huge. And keep putting money, it's not going to change it. Doing fancy stuff, not going to change it. You need to convince students that it is in their best interest to start studying. And actually, there is a great book, just listen to Thomas Reimann, World is Flat. Oh, yeah, but he's talking exactly about the same thing. He's saying the world is flat, all the CEOs and big guys know about it, but nobody knows what it is. It's a great book. And by the way, what's happening open courseware that MIT has? That all these programs are actually used back in Asia and in Eastern Europe. They love it because they know what to do with it. Hey, so we have to sweat.
You know, the ideal scenario would be if all students suddenly got interested.
And they started doing these things, and we didn't have to spend as much money trying to convince our kids that somehow what we're doing is not good for them. That would be the best case scenario. However, we've tried that best case scenario for 40 years. Okay. Yeah, it's a very good question. Well, by the way, you're not the first person to ask me this, okay? You definitely are not the first person to ask me this, okay? If you see, I also target cell phones. Okay, on a college campus, there is a survey from, I think, Educos that shows that women spend more time on cell phones than they do on games. Okay? I'm not meaning to stereotype this, but this is based on true data.
Is there any quantitative evidence to suggest that even something as simple as having laptops, there are a lot of school districts that aren't getting laptops to their if they're high schoolers or maybe junior high. Is there any evidence to suggest that actually helps them understand like basic concepts of physics and chemistry that really aren't computational? You have to understand the basics before you understand.
Right. There is no evidence with laptops. However, there is evidence with games. Okay. Nature magazine published an article in September of 2003 which shows that game players have better memory and better visual skills than non-game players, and they demonstrated the transfer of skills in math memory. Okay. And then there is also a cognition and technology group at Vanderbilt that has just put out 2 or 3 studies that show that game playing actually improves the ability of students to score on tests, particularly if the learning is tacit. So there is concrete scientific evidence. I have problems with the laptop thing because I don't believe personally that distributing laptops to students or requiring them to use it is going to change anything in the classroom, particularly if they're going to chat with each other. Okay, so that's probably one of the things that I agree with you on. That
most of the time, teachers at that age aren't being taught how to incorporate those into their teaching. So yeah.
Right. I seem to have stirred up quite an hornet's nest here, but I'm really happy because this is exactly the intended impact. All right. Yeah, I want this.
One question and one comment. I'll do the comment first. I'm in charge of the introductory curriculum for the school. I teach large classes. I don't allow any kind of technology in the classroom. I think it's a matter of stability, not necessarily learning, but I would advocate the use. My question, though, is technology seems well suited for these scientific disciplines, but if you're teaching something like English literature, let's say poetry, I'm not quite sure the transfer is as easy. I'm curious if you guys have thought about these less easily grasped on digital type of areas.
Right. Actually, in particularly discipline-specific area in English, there is a lot of literature from natural language processing, okay, that seems to support automated training for students, particularly those weak with writing skills and those weak with reading skills. I've personally worked on this on such projects and I've published on this. Okay. That being said, not all areas are covered. So the real challenge to us is how are we going to pull those people in? Okay. Here we are working on the cutting edge of science and technology. How are we going to, somehow bring other people in who are not engaged in this?
Short answer, through art projects. Imagine the art that can be done using this kind of technology.
Oh, there you go.
Do you have any assessment plan on how to evaluate the outcome of students by new graduates?
Right. So we have a very concrete assessment plan in place. There are some methodologies that allow us to evaluate, for example, game players versus non-game players, cell phone users versus non-cell phone users. These are also embedded in market research a lot. How do you target certain products at certain people, and how do you know the product is succeeding? That literature informs us. So there is some research plan in place. However, as I pointed out, this is just a project starting up. This is a brand new concept, and we think that this is going to work. And this is a true experiment, okay? If it fails, it fails. Part of risk taking. But yes, we do have a concrete assessment plan in place.
Well, thanks, Krishna. And I want to thank all of you that actually made it to the end. And your reward is actually food and drinks and more socializing. It's actually down the hall. Don't go out the doors. Take a left before you get to the doors, to the right, and then down there, the health room. In there, there's food over here. Also, we'll be sending the DVD with the presentations and all the materials on it after we get it all finalized. And the great guys in the back who were keeping us on track. We get that to them. Again, the surveys, if you could fill in some information on that, we'd really appreciate that. If you want to send anything electronically, feel free to send it to Microsoft.com alias. And if you've lost anything and you ever lost the cable that still hasn't come and gotten it from me, if you get back and find you're missing some, let us know. We'll have a little lost and found here. So I want to thank again everyone for coming and participating. All the speakers.
Thank you.